Hi everybody, and welcome to exercise 4 on page 26 of the workbook. And in this problem we're going to be finding the equation of a plane that contains 3 points. Okay, I'm going to label these 3 points that they're giving us P, Q, and R just to make the process easier of doing this. Okay, and the strategy that we're going to use to do this problem is to try to use the 3 points that they've given us to find a normal vector to the plane. Knowing what a normal vector is a really nice piece of information to have, okay, because we have a general formula for the equation of a plane that looks like this. Okay, and this is the one that we're going to use. Okay, and the A, B, and the C that you see here, here, and here are the components of a normal vector. Okay, it's our goal to figure out what those components are. All right, so let's draw a little picture here. This is going to be just a very rough diagram. It doesn't need to be terribly accurate, just to get an idea of what we've got. Okay, we've got 3 points that are somewhere on this plane. Okay, without worrying about exactly where they are, I'm just going to assume that they're here, here, and here. Okay, and to find a normal vector for the plane, here's what we're going to do. Imagine playing connect the dots here. We're going to draw the vector QP and the vector QR. Those 2 vectors are in the plane, and so we can produce a vector that's perpendicular to both of those by taking the cross product. Okay, and that's going to give us the vector n, the normal vector that we're looking for. Okay, so the key then is we need the 2 vectors in the plane, the blue vectors, in component form if we want to be able to find their cross product. All right, so let's start with the vector QR that goes from here to here. How would we write down its components? Okay, well, from Q to R, we're starting at Q and we're ending at R. Okay, so we just need to subtract coordinates to get that vector. So if we go from 2 to 3, that's going to be 3 minus 2i. Okay, and then we're going to go from 3 to negative 1. So that's going to give us negative 1 minus 3, j, and so on. 2 minus 0, k. And so if we do the simplification, that's going to work out to be I minus 4j plus 2k. Okay, there's the vector that takes us from Q to R. Okay, and let's do the same thing now for the vector Q to P. We can subtract the coordinates, okay, to come up with a vector for that. Okay, and if we do that, so starting at Q and ending at P, we'll get 1 minus 2i plus 2 minus 3j plus negative 1 minus 0k. And if you do the arithmetic there, you're going to wind up with negative I minus j minus k. Okay, so far, what we have are component-wise descriptions for QR and QP. Okay, and again, to find the normal vector n, we're just going to take the cross product of those 2 vectors. So QR cross QP, that involves taking a determinant. Okay, so the second row in our determinant that we're calculating is going to be the vector QR. So let's see, that has components 1i minus 4j plus 2k. All right, and then QP has components of negative 1i minus 1j minus 1k. Okay, and we've done a few cross product calculations by now, so I'm going to skip the details here and just write down the result after you do the cross product. You may very well have a calculator that can do a cross product internally, and you're certainly welcome to use your calculator to do that. Okay, so what we have just calculated then is a normal vector to the plane. Okay, so kind of looking back at the equation that we're going to be writing, the components of that vector are going to be the A, B, and the C, 6, negative 1, and negative 5, it turns out. All right, what else do we need to know besides the A, B, and the C to find the equation of a plane? Well, we need a point, x naught, y naught, and z naught. Do we know any points on this plane? Actually, we have 3 points on the plane already that are given to us, and so we can choose whichever one we want. Let's get rid of our labeling here. How about if we choose the first of the 3 points, 1, 2, negative 1, that means that x naught, y naught, and z naught are just going to be those 3 numbers. Okay, combine that together with the fact that the a, b, and the c are just going to be the coefficients of the components of our normal vector, and we're ready to write down the equation of our plane. Okay, so the equation of the plane is going to look like a, which we can see up here as 6, times x minus x naught. Okay, x naught is sitting up here, 1, plus b, which is negative 1, times y minus y naught. Y naught is the 2 that's sitting up there. Okay, plus c, which is negative 5, times z minus z naught, and the z naught is sitting right here, negative 1. Okay, we can simplify that a little bit. So 6 minus 1 minus y minus 2 minus 5 times z plus 1 equals 0. That should be the equation of our plane. Okay, and that would be a good final answer that we could give. And just one comment here. Sorry about my writing here. That's a correct answer, but you could, if you wanted to, put that into standard form by actually distributing the numbers through. So take that 6 and multiply it through x minus 1 and do the same with the other coefficients. And if you did that, another way of writing this answer would be this. And just want to put that here as a second possible way of writing this answer. Okay, it would work out to that. Either of those 2 answers would be correct.